Welcome back to the channel. Today, we're continuing our route filtering series, and in this one, we're talking about route maps. If you've been following along, we've already covered filtering using access lists, and we just wrapped up prefix lists. Now, we're stepping into the next level, a tool that gives you much more control and flexibility when shaping routing behavior. Route maps are used everywhere: redistribution, filtering, policy-based routing, conditional logic. Basically, anytime you need the router to make a smart decision instead of a simple yes or no check. So, in this video, we're going to break down what route maps are, why they're used, how they work, the key commands, and then walk through an example. Let's jump in. So first, what exactly are route maps? Route maps are like conditional policies for your router. They work almost like an if this, then that rule set. Instead of relying on just one condition, like ACLs or prefix lists, route maps let you match multiple criteria and then apply action to the routes that match. They can filter routes, change attributes, influence path selection, or completely redirect traffic. They have match statements to identify routes and set statements to define what you want the router to do with those routes. Think of ACLs and prefix lists as filters with script rules, black and white. Route maps are more like policies with logic. You get shades of gray and more control. So why use route maps instead of sticking with ACLs or prefix lists? The biggest reason is flexibility. ACLs and prefix lists can only match. They can tell the router yes, permit this, or no, deny this. That's all. Route maps take that a step further. With route maps, you can filter specific routes, match multiple conditions at once, modify route attributes like metric or next hop, control redistribution more precisely, and influence routing decisions based on policy. Another big advantage is that route maps allows you to build multiple sequences. Each sequence can match different things and apply different actions, all under one policy name. So instead of multiple ACLs doing multiple jobs, you can combine all your logic into a single route map and apply it cleanly. That's why route maps are used across routing protocols. They're simply more powerful. So here's the basic idea behind how route maps are used. You always start by identifying which routes you want to match. Most of the time, that's done using either an ACL or a prefix list. The ACL or prefix list defines the networks, and the route map just references it with a match statement. Then, in the route map, you decide what happens to those routes. You can permit them, deny them, or modify attributes through set statements. Finally, you attach the route map to a routing protocol. Depending on the protocol, you might apply it inbound, outbound, or during redistribution. In short, step 1, create the filter with an ACL or prefix list. Step 2, build a route map policy. And step 3, apply the policy to the routing process. And once you understand that flow, route maps start to make a lot more sense. Now let's look at some key commands involved in building a route map. A route map begins like this: route map, name, permit, sequence number, or route map, name, deny, sequence number. That line creates the policy and the sequence number. Inside that sequence, you'll use match IP address prefix list, set metric, set IP next hop. You might not always use a set statement when filtering. If you just want to permit or deny routes, the match and the permit deny are enough. And finally, once the route map is built, you apply it to a routing protocol. For example, with EIGRP. Router EIGRP 10, distribute list, route map, name, out. These few commands form the backbone of almost every route map configuration. Let's break down what each part of the route map actually means. The route map name identifies your policy. This name can have multiple sequences under it, each handling a different condition. The permit or deny keyword determines whether the match routes in that sequence are allowed or blocked. The sequence numbers controls the order. Lower numbers come first, and the router moves down the list until it finds a match. The match statements specify which conditions must be met. This is where your ACL or prefix list comes into play. It defines the actual networks. The set statements allow you to change something, like the metric or next hop, but they're optional. For basic filtering, you may not need them. And finally, the distribution or routing protocol command applies the route map so that the router knows when to use it. Once you understand the meaning behind each part, route maps become a lot easier to build. Now let's walk through an example of how route maps filter routes. Let's say R1 is advertising 3 networks to R2, and R2 should only pass one of those networks to R3. Step 1 is to identify the specific network you want to allow. So we create a prefix list that matches that single network. Next, we build a route map with a permit sequence that matches only that prefix list. That becomes our allow rule. Finally, we apply the route map outbound on R2. The result, R3 will only learn that one allowed network and the other 2 will be filtered out. This structure works across all routing protocols. Here are a few key terms you'll want to remember. Match, the conditions a route must meet before the sequence applies. Set, optional actions the router will take if the match succeeds. Permit, deny, states whether the route is accepted or rejected for that sequence. Sequence number, the order the router checks each rule. Prefix list or ACL, defines the actual networks you want to match. And route map policy, the entire structure that ties the logic together. Once you know these terms, reading route map configurations becomes a breeze. To wrap up this concept, route maps provide powerful, flexible routing control far beyond basic ACL or prefix list filtering. They let you match routes with precision, apply logic and sequence, and even modify attributes when needed. The process always follows the same flow. Build your match criteria, create your route map with permit or deny logic, and apply the route map to the routing protocol. And with just a few commands, you can filter routes cleanly and predictably. If you've been following this route filtering series, this piece gives you the full picture of how real-world routing policies are built.